Hello. I just wanted to say hi. I'm going to do this screencastify. I'm going to turn my face off in a second. But it's good to see y'all. I'm hoping that you find this useful. I'm going to dictate over this PowerPoint. We're going to go through some problems. A lot of you guys were doing really good work, but not totally complete work and not using the right notation. So this is going to boil down some notation and show you some good examples by the end. So I hope you guys are well. Please reach out to me with any comments, questions, concerns, issues, and I'll see you later. Bye. Okay, so, screencast. All right, so this is finding antiderivatives given derivatives. This is the integral sign. An antiderivative is the inverse of a derivative. That's the operation associated with taking the antiderivative. That's called integral. So we notate the integral with the symbol to the right. So that's over there. Okay, we can use the idea to find the original function, which is given the derivative function. So logically speaking, we are taking a speed and then finding a location. So we can think about, if I know how fast I'm going, I know exactly where I am, as long as I have a teeny tiny bit of information, which is what you guys have been working with the particular solutions. But here we have the antiderivative and the indefinite integral statement. So a lot of words here. The indefinite integral statement represents a family of functions that could have created the derivative in question. So this is why we're required to write that constant of integration, which is that plus c. And we call the f of x that integrand. The differential is that d of x in the indefinite integral, which tells me what the variable in the antiderivative will be. So I'm going to turn this pointer on. For example, if this was a t, this would have to be a d of t, which would tell me that my answer would have a t in it. And that goes for any other variable. So if I'm integrating with respect to y, if I'm integrating with respect to x, t, v, q, r, x, whatever. They both have to match. So your differential has to match, your differential variable has to match your integrand variable. Okay, so be reminded that f of x in the integral function is a derivative. So you don't have to write that prime, but that is that biggest thing to get used to, if you will. Since the integrand is the inverse of a derivative, we have to use a derivative in order to use it. Okay. Let's work through some particular solutions. So once we're given some information, we can find out what C is. So this is this initial condition that I've been giving you. F of x is equal to y. We're able to solve for that C. Okay, so here's my first question. So I have, find the particular solution f of x given f prime of x is 2x when f of 5 is 10. So I'm going to start with using my integral statement, which a lot of you guys were forgetting. And then I'm going to plug in my derivative, which is 2x, and then we have a variable of x, so I'm going to write that dx there. Okay, we're going to use our simple integration rule, and I'll get x squared is equal to c. I know that that's my new f of x now. Okay, that's my new solution. Now we need to make it particular. We're going to use this information that I have here. Okay, so I have f of 5. I'm going to plug in 5. So I have 5 squared plus c is equal to 10. 25 plus c is equal to 10. And then once that goes away, you can see that. You're going to have negative 15 is c. And then you have to reconstitute your solution. So put it back together. So you have x squared minus 15 is your answer. Okay. And now let's do another one. I have f prime of 8 when f of 2 is equal to 3. So I start with my integral sign. Integral of what the derivative is, 8, and then you plug in the dx. Okay, using my simple constant integration rule, I know that that's going to be 8x plus c. I know that that's my new solution. Not particular yet, but it's my new solution. So I'm going to write that as f of x is equal to c. I'm going to use my initial condition that I have, this initial condition here. So I have f of 2, so I'm going to plug in 2. 8 times 2 plus c is equal to 3. 16 plus c is equal to 3. I have c is negative 13 just by doing simple algebra. And then I'm going to put my function back together. We're going to put the function back together. Okay, please reach out with any questions, comments, concerns. Bye.